Hello everyone, welcome to the end of week 2, the 2014 FRC season. Here today we decided on a final drawing, final design for our robot. So we'll be using a catapult system. As you see down here we have sort of a forklift lever. So the end is curved, so we'll be able to pick up the ball easier. To power it, we have a winch that's connected to a spring or an elastic band. So bungee cord or latex tubing, very stretchy. This will lower, this will be a dead axle here, so it'll rotate. This winch will, once this side goes down, it'll lock in place, and this winch will start winching, and then it will stretch the elastic band, and then it'll store up enough elastic potential energy, for those of you who have taken physics, and then once it winds up all the way, the latch will release, and the ball goes flying.
So today when we calculated what our velocity and force need to be, we found our total velocity from here to be about 7.7 meters per second. So we tested this outside, and our horizontal velocity was supposed to be about 4.04 meters per second. So when we took videos of it and look at the frames, we found that our actual velocity, horizontal velocity was 3.16 meters per second. So it's almost 1 meter per second off, but because of air resistance, we found that the methods that we used were valid. So we went with 3.16 meters per second, and we attempted to find out how much force we would need to power lift the ball and shoot it out at 7.7 meters per second. So through some calculations, we found that we need about 11 pounds of force to shoot the ball 7.7 meters per second at an angle of 58.6 degrees. And that's at a distance of 5.5 feet away.
So we're building field equipment in order to simulate some of the environment that we have on the playing field. So we're building a high goal and a low goal. We're building them together just for efficiency purposes. Notice that we built the high goal will not be as wide as it's supposed to be, but we have the height limitations very, very exact. The low goal is cubic in nature and has entry points here, here, here. So we'll be making sure that these spaces are dimensionally correct in order to give the best simulations possible. It will be built out of PVC pipe. It's not going to be perfect in terms of construction, but it will be close enough to suit our needs.
So today we finished some of the things on our task list. We finished calculations. We finalized the design. We actually don't need cardboard anymore, so good about that. Building a prototype, however, we will be doing that in the next few days, so that's something we need to work on. Field equipment, George and Ronnie did a job of starting on the field equipment. Bumper team, it would be nice if we could start getting bumpers together. Also, review, if you're going to be building bumpers, review the however many pages, 6 pages was it? In the game manual, just on bumpers. So bumpers are very important. I don't want to have it thrown together last minute like last year, because those are a pain to do. Cart building, that could wait for a bit longer once we have...
The cart can wait for later.
Yes.
Okay, what's that last one?
Driver station. Driver station is also very important. If you didn't know, the driver station holds the laptop and whatever controllers we'll be using. So someone could also start working on that over the next few weeks. As it is getting closer to the end of build season, getting closer to competition, we will, we're on week 2, February 18th is the end. But as it gets closer to the competition, we will expect you to know more and more about the safety manual and the team manual, so be sure to study up on those. We might have a pop quiz, we might, hint, maybe not. But just know your stuff, know the manuals,